Hello everyone, welcome for the next session. So we are back. 150 must two questions. So I hope you're ready to discuss and to try the questions, the most expected kind of concepts that we have seen through the years, and some new things that we expect the exam to put put forward, right? All right. So I hope so. This is the time, less than 100 days, and we want to come across as many different new type of questions, which uh, you know, which the exam can ask, right? Or the concepts that can be tested, which have been frequently asked, and also some new things. Okay. So with that agenda, let's start the session. 150 must do questions. Before that, just to let you know that Open CDC 3 mock is there for which you should look up to it. One of the many ways that you can prepare is to take a real feel of the exam, right? So book it, book your seats now for this. Uh, right, most of the serious aspirants have been taking the CDC mocks with us, right, and gaining and getting to know their real situation. You can say by getting the real feel of the exam. Okay, so with that in mind, I hope you will take you know you will take perhaps this mock to better judge yourself, I would say, right? Let's start with the session. Here we go, people. Question one. All right. So remember how I do take this session is uh, I just let you give you a few seconds to just read the question. Then we'll start it together. So it will be a race. Who gets to solve the question first, right? So I'm looking on the chat box. If you get the answers, do let me know. All right. I'll declare the names and then we'll understand that who solved it first. Okay. So here we go. The first one. A reduction of 20% in the price of sugar enables a housewife to purchase 1 kg more within her monthly budget. So, obviously, if the price goes down, you'll be able to buy more for the same amount. Remember, the keyword is within her monthly budget, which means that she's spending the same total amount. So, what is the relationship between price and amount spent? Right? Can I say the amount spent A is the price into the quantity purchased, right? So A equals P into Q. Like for example, if let's say the sugar costs you 50 rupees per kg, and if you're buying for 4 kg per month, so you are spending 200 bucks on that, right? 200 is what? 15 to 4. So A equals P into Q, right? That is the relationship between these three quantities. Now, what happens to the price? The price decreases by 20%. 20% is 1 by 5. So it's a decrease of 1/5. So the new price is 1/5 less than the original. So it is 1 minus 1/5 of the original price, or it is simply 4/5 of the original price, right? So this amount is not changing, right? This amount is still what it is. So A equals, if the price has become 4/5 of its initial. So to balance the change over here, which is 4/5, the quantity which is now which can be bought must become 5 by 4 times, so that the same amount is maintained, right? So the new quantity bought is 5 by 4 times of the initial. This 1 kg is what? The extra that she can buy, 1 kg more. So therefore, the extra quantity is what? 5 by 4 q minus q, or q by 4, right? So the extra quantity is q by 4, right? And that is given as 1 kg. So our q comes to be 4 kg. So from this statement, we are able to interpret that she can buy, basically, she originally used to buy basically uh, 4 kg, right? She initially used to buy 4 kg. This is what we can understand. Now, so Then the question says that is if instead the price had reduced by 10% and her monthly budget increased by 35%. So now the things are changing altogether. Amount is also changing and price is also changing. So the new amount the new amount that she can spend is 35% more. First of all, right, she has increased her monthly budget by 35%. 35% is 35 by 100 or 7 by 20. So the new amount is 7 by 20 fraction more than the original amount, or this is 27 by 20 times of the original amount, right? This is the new amount. Then what about the price? The price had reduced by 10%. So new price in this case is what? 90% of the original, 9 by 10 p, right? So we have to find the new quantity that she can buy. Remember, q was 4 kg. So the using this q equals 4 kg in the initial equation, this one, can I say the amount that she used to spend was basically 4p, right? She used to spend 4p amount. A equals 4p. So now new amount equals new price into the new quantity, right? The new amount is 27 by 20 A, and from here A is 4p. So 27 by 20 into 4p equals new price, which is 9 by 10 of p, into the new quantity. So I think this equation will finally give us the answer. P cancels on both the sides. We can further simplify. This 10 goes off, this 9 goes off, 3, and this 2 also goes off with this 4. So the new quantity is coming to be 3 into 2, 6 kg, right? So therefore, if she is able to buy 6 kg, how much more this is than her initial? She was initially buying 4 kg, now she is able to buy 6. So it's a 2 kg that she can buy more, right? So with this, it was all about percentage change, right? So I have thoroughly used the concept of multiplying factor, right? And I have used the uh, you know I've used the basically the basic relationship between the three quantities, which is amount is price into quantity, right? All right. So I didn't get the response on the first one. Maybe we were in a slow mood. Okay, so buck up. You can do this. All right, so participate. Show me that you can do these things. Let's do it together and get it faster than me. Okay, next one. I'm giving you 1 minute to digest this question, to understand it, and please start trying. Okay. All right, let's see. So you can see that there are four fruits about which the problem is giving us some interrelationships. So look at the statements. The first statement talks about mangoes and guavas. The second statement talks about apples here, bananas here, guavas here. The third statement talks about apples, guavas, and bananas. Can you see one thing? The second and the third statements, both of them are talking of the same three quantities, which is apples, bananas, guavas. So this is the best starting point. This can help us to get some kind of basically the objective is to find the ratio of the number of fruits of the four kinds. So we have to establish the ratio amongst these four parameters over here, right? So what I'm saying is that if you so one reason that I've put this question over here is to make you understand that before you start to create the variables and start framing the equations, like this question looks like that, we have four things. Don't do it just blindly by looking at the very first statement and start writing the equations based on the very first, right? First get the overall situation, right? So obviously Second and third statements you should start with, not the first statement. We can use the first statement as the last after maybe getting to solve the second and third, right? So I'll take three variables for apples, bananas, guavas, A, B, G, let's say, right? And then I'll see that what we get from there, and then we can perhaps move further, right? So 25% more, something is 25% more, 1/4 more, so it is 5 by 4 times. So number of apples are 5 by 4 times of total of bananas and guavas. So equation can be written that A apples is 5 by 4 of bananas and guavas, or 4A equals 5B plus 5G is my first equation. Then the total number of apples and guavas is, so second equation is apples plus guavas. So this is given to be simply equal to 5 times of the number of bananas. Second equation. I can see 5b here, 5b here. So I can equate the value of 5b, can I say? So a plus g equals 5b, and from the first equation 5b also equals 4a minus 5g. So finally, I have got a direct relation between two variables a and g. So that will give me the ratio between these, right? So I'm getting 4a minus a, or 3a equals 5g plus g, 6g, or simply a is twice g. So if a is twice g, so I have got one thing very obviously, that the ratio of them is 2:1. Apples is to guavas is 2:1. Now, at the same time, I can then come back to the B, right? I can define B in terms of A and G. So from the second equation, 5B equals A plus G. Can I write A as 2G from what we have got over here, right? So 5B equals A is 2G plus G. So 5B equals 3G, or B by G, B by G is 3 by 5. So from here, the ratio of B to G we have got as 3:5. Now, so can we merge these two ratios, apples and guavas in the ratio of 2:1, bananas and guavas in the ratio of 3:5? The common thing in both of these ratios is the guavas. So 5 here, 1 here. I should multiply this ratio with 5. And I'm now merging the ratios. So apples, ratios, guavas, ratio, bananas, right? So this becomes A is to G, 2:1 becomes what? 10:5. And at the same time, if guavas are 5, bananas are 3. So 10:5:3 is the ratio of these three types of fruits. Then we can move to the first statement, right? So from this ratio that we have got, can I say that apples we can take as 10k, guavas as 5k, and bananas as 3k? So for every 6 mangoes, there are 5 guavas. For every 6 mangoes, there are 5 guavas. Now in this ratio, I have already written guavas as 5. So if there are 5 guavas, there are 6 mangoes against that. So simply I can connect this ratio here, that mangoes are 6 in this continued ratio. So apples 10k, guavas 5k, bananas 3k, and we can also include mangoes to be 6k in this final ratio, right? This is what we have got. Now what's the question? Question is not asking the ratio, but this is the conclusion of the information. Now we can move to actually address the problem. The basket has currently the minimum possible number of fruits that satisfies these conditions. That simply means that for this ratio, which we have already written in the simplest form means there can be no further simplification of this ratio. This is already in the simplest reduced integer form. 10:5:3:6, right? So the for k equal to 1, we have the minimum possibility. So that's what he's saying. Assume that the number of the fruits is minimum possible, which is that apples are 10 itself, guavas are 5, bananas are 3, and mangoes are 6. So at least how many more fruits need to be added to the basket so that there are an equal number of each type of fruits. Right now, the fruits are not equal. We want them to be equal. So the role over here of apples becomes the most important because they are the highest as number. I have to add the minimum number of fruits. At least how many more fruits need to be added. So guided by the fact that we have 10 apples, we need to make each of the other fruits at least 10. And that is what we need to reach. So guavas we need to increase by 5. 5 plus 5, 10. Bananas we need to increase by 7. 3 plus 7, 10. And mangoes by 4. 6 plus 4, 10. Then each of the fruits will be 14 number. How much we have added all together? 5 plus 7, 12 plus 4, 16. Right? So 16 fruits need to be added, respectively 5 guavas, 7 bananas, and 4 mangoes. Right? So a very good question on ratios. How equations help us to simplify to get the ratios. That is the first part, right? And then merging the ratios and then addressing the problem at hand. So this is a multi-layer problem, right? This is how the questions, the complexity increases. First you solve the ratio and then you come to the actual problem. All right. So any doubts, do let me know. I'm there, right? I'm looking on the chat box. If there are any queries, do let me know. Okay. Now, let's start with the next one. Let's try together. Let's see who can do this fast. Now, this question is basically about removal and replacement. Let me discuss the core idea of this question. Whenever there is a solution, okay, of anything, let's say milk and water, okay, like here we have milk and water, and there is some milk, there is some water, and there is some initial volume, let's say 100 liters, and let's say we take out 20 liters of the solution and we pour back 20 liters of water. So this is called removal and replacement, removing some part and replacing it with one of the two things. Okay, so the idea in this problem, this kind of situation, is whatever you're pouring in water, right, that concentration obviously of that will obviously go up, and so the concentration of the other part, which is milk, will obviously decrease. Let's say the question is that this process is repeated 5 times. Okay, what is the final concentration of water? So the concept is, whatever you are diluting, the percentage concentration of that decreases by a percentage which is exactly the same as the percentage of solution that was removed. Means milk, whatever is the initial concentration, right, let's say 80%, okay, and 20%. So you remove 20% of the solution, right? So the milk concentration will go down or decrease by 20%. So the new concentration will, let's say, will become 80% off, because 80% means decrease by 20%. So 80% off the initial percentage, which is 80%, which is 64%. And if you do this process once again, then again it will decrease by again 20%. So the new concentration next time will be 80% of 64%, and so on. So that's the basic idea on this problem over here. The concentration decreases by as much percentage as is the fraction of solution that is removed over there. Right now, so we have 50, 40, and remaining 10% of sugar. 50% milk, 40% water, rest is 10% of sugar. So now this solution is of three things, right? The concept does not change. 1/4 of the solution is removed and replaced with milk. So since 1/4 of the solution is removed and replaced with milk, so whatever other constituents are, right, their respective concentrations will go down by 1/4. That is what is going to happen. And again, so that will give you the respective concentration of the other two constituents by decreasing them, right? So that is what you have to find, that at each stage, what is the respective concentrations of the three constituents that we have, right? So first we are putting milk, so the water and sugar will concentration will decrease. Okay, fine, Anushka, we'll just check if that is correct. Thank you. While I was explaining, one person has already got this. Very good. Yeah, Anushka, that is correct. Thank you. Okay, so let's do this. We are starting with milk, which is 50. We then have water, which is 40. And then we have the rest of sugar, which is 10% initially. Right? This is the initial situation. In the first step, step 1, since milk is being added, so we'll find the respective concentrations of water and sugar by decreasing by 1/4, right? So decrease of 1/4 means the concentration becomes 3/4 of the initial, right? So 3/4 of 40 or 30% of water remains, and 3/4 of 10%, which is 7.5% of sugar remains after step 1. This is 37.5, so the remaining of milk becomes 62.5, right? 37.5, 100 minus of that, 62.5. Then again, step 2, what happens is, step 2, 1/5 of the solution is removed and replaced with water. Now we are pouring water by the measure of removing and replacing with 1/5 of water. So the concentration of the other two, which is milk and sugar, will decrease by 1/5. So decrease of 1/5 will happen on the concentration of milk and sugar both. So one decrease by 1/5, right? So 62.5, 1/5 of that is 12.5. 62.5 minus 12.5, which is we are remaining 50% milk. We are back to where we started with, right? We started with 50, we are back to 50, right? And 7.5, 1/5 of that is 1.5. 7.5 minus 1.5, so you're left with 6% of sugar. So 56% total for milk and sugar. The remaining of 44% will be your water. So now check from the options. Uh, Quantity of something remains changed. Milk or water? Obviously milk. Quantity of milk, yes, remains unchanged. And the first one is saying quantity of sugar decreases by 20%. Now quantity of sugar has decreased from 10% to 6%, which is a decrease of 40%. The final concentration is 6% with respect to initial of 10%. That's a drop of 40%. So option D is correct. That quantity of sugar decreases by 40%. Right? Perhaps good for people like me who are trying to avoid sugar. Right? Good result. All right. Same milk, but decrease in sugar by 40%. All right. So this was removal and replacements. Questions have been asked directly on the concept of this. All right. People, good, Anushka. Now, next one. Races, time and distance. Now, let's see who is fast. Race against time. Okay, I'll give you a minute to try this. No options right this time. Theta question. Okay, so I hope you're trying. Now, let's start. A was behind in the race initially, right? He was running at 5 meters per second for the first 2 kilometers. B was leading the race. It's a 6-kilometer race. Then A increased his speed by 50%, which means 5 meters per second now becomes 7.5 meters per second. He then overtakes B at the 4-kilometer mark. It would be good if we could somehow figure out what's the speed at which B is running. Understand one thing. After 4 kilometers, A and B both have reached the same point. Means they started at the same time, and if they are in the midway at the 4-kilometer mark all together at the same time. What does it tell us? A has changed his speed over the course of 2 kilometers and then 2 kilometers. Whatever is his overall net average speed because of this is the constant linear speed at which B has been running the race. Once again, A and B are together at the 4-kilometer mark at the same time. Whatever is the net effective average speed that A has achieved because of first part 2 kilometer, then second part 2 kilometer, 5 meters per second, 7.5 meters per second, whatever that average speed is effectively must be there that speed of B at which he has been running, isn't it? So this is the decoding of the problem first of all, right? So therefore, now we can start off having understood what needs to be done. This is the race. This is the 2 kilometer mark. This is the 4 kilometer mark. And this is the final, you can say the end point, right? The 6 kilometer mark. So A, who has been behind, he ran over here for 5 meters per second, then over here at the rate of 7.5 meters per second. A and B are together here, right? A and B are here all together. So we are trying to find the average speed of B, which is equal to the average speed of A also after the 4 kilometer mark. So average speed of A is average speed is total distance by total time, total distance covered by total time taken. So 2 and 2, 4 kilometers is the total distance covered by A. Divide by total time taken. Total distance by total time is average speed. Total time is time in the first portion and time in the second portion. Time in the first portion will be distance by speed. So 2 kilometers by 5 meters per second. Right. I'm letting this be in kilometers. I think I should multiply this with 1000 to make it meters. But I'm letting it remain in kilometers only. Plus another 2 kilometers by 7.5 or 15 by 2. 2 comes on top. 2 into 2, 4 here. So this is this much. This is meters per second. Okay. So take the LCM. This is 4 kilometers, or now I'm writing just meters. 4000 meters upon LCM of 15 comes on the top, right? And this is 3 into 2, 6 plus 4, 10 kilometers, or 10 into 1000 meters. So this 1000 in any which way cancels, you can see. And we are getting basically 4 into 15, 60, 60 by 10, 60 by 10 or 6 meter per second is the average speed of A, which is the average speed of B. Now we know that over here, B is running this race at 6 meters per second. He will continue to do so because nothing is mentioned. Whenever nothing is mentioned, the speed of a person always remains constant. So B is now running at 6 meters per second. A, on the other hand, we know is much faster at 7.5 meters per second. So obviously A will win the race. We have to find the margin, right? So the speeds of A and B are in what ratio? What is the ratio of the speeds of A and B? 7.5 and 5. 7.5 and 6. So what is the ratio? Simplest form. Multiply with 2. So 15 is to 12. Cancel 3. So 5 is to 4. Finally, people are giving me the answer. Thank you, Anushka. Thank you, Prashant. Both correct. Right. So therefore, now we know that it's a 2000 meters effectively. Effectively, they are starting all together at the 4 kilometer mark. They have 2000 meters in front of them. So when A will cover 2000, how much will B cover? Obviously, the speed, the ratio of speed is also the same as the ratio of the distance that will be covered by them, because they're running for the same time, right? So in the same time, people run the distance in the same ratio as the ratio of their speeds. So 5 is to 4. This is 2000. 5 into 400 is 2000. So 4 into 400 will be 1600. So B loses the race by a margin of 400 meters, right? 400 meters, right? Thank you, Prashant. Thank you, Nishka. All right. So races. Races have not, I've not seen a very direct question in the last year, I guess, but it can come up, right? So always remember, whatever thing has not been asked in a long time, the more the probability it will appear up, right? Because cat moves in cycles. Okay. I have seen a kind of a pattern, something does not come for 2 3 years and then suddenly comes up. For example, we have seen a strong return of numbers direct questions in recent years, right? That had gone a little bit down. All right. Okay, good. Let's just keep on trying. Geometry figure is given in front of us. Okay, I'll give you 1 minute to try this. Figure is there already in front of us. Let's see if you can get this. Okay, so I've given you enough head start. If you're able to get this, do let me know. Now, so you can see a lot of circles which are touching each other, right? The two blue circles are congruent, right? So since they are meeting at the center of the larger red circle, obviously the radius of the blue circles is obviously half of that of the red circle, right? The radius of the red circle becomes the diameter of the blue circle. Now we are more concerned with the blue and the orange circles, right? As the question has asked us for the ratio of their radii, orange to blue. Obviously, orange circles definitely are smaller than the blue circles. That is why you can see all the ratios are less than 1. Right. Anushka, I think this time you're guessing. You're doing an intelligent guesswork just by the way, right? But you're not solved it mathematically, right? Uh, so guesswork is sometimes work, sometimes does not work, right? Let's see. Aditya, also you're doing thinking the same. 1:2 looks like it. Now, I'll give you one mantra, right? I'll give you one yardstick, one rule. Mostly and typically circle problems are solved by joining the radial lines, means connecting the dots, join center to center, and typically right triangle angled geometry construct gets constructed or gets used once you do that construction. So obviously this question requires construction. A smart way of doing that is required. So connect the dots. Okay. For this blue circle, somewhere over here we'll have the center. For this orange circle, we'll be having the center somewhere over here. Connect them. We know that when two circles touch each other externally, then the line joining them passes through their point of contact. So therefore, if I join this line, it is going to pass through this point of contact, essentially telling us that this line, if this is, let's say, center is O1, this center is O2, then O2 to this point P is the point of contact. This O2P is, let's say, R, capital R, for the radius of the larger blue circle, and O1P is small r, let's say, the radius of the orange circle. Now we don't have any when we don't have we yet not have formed any as such triangle, but we need to do one more smart thing. These two blue circles which are touching each other at this point, connect these centers to this point, let's say point Q. So obviously this O1 O2Q is obviously a right angled triangle, right? Because simply O2Q is the radial line, O1Q will be tangent to this blue line, right? Now we need to define the dimensions of this triangle in terms of the radii. Obviously O2Q is simply the radius as well of the large blue circle. What about O1Q? What about O1Q? Can I say if I extend this O1 to this point, let's say X, this QX is obviously the diameter of the blue circle, the radius of the red circle, which is twice the capital R that I have taken. Once again, a QX, right? It is nothing but the radius of the red circle. Since the radius of the blue circle is R, so the radius of the red circle is 2R, obviously. Then this O1X is small r. This O1X is small r. So this QO1 basically comes to be 2R minus R. Now we have defined all the things in terms of our radii. Then we can write the equation that O1Q square, right, plus Q plus O2Q square, right, equals O1 O2 square. This will give us the required ratio, right? Pythagoras theorem coming to our rescue. Okay. So O1Q 2R minus R whole square plus O2Q simply R square equals R plus R whole square, and we can further simplify. 4R square minus 4RR plus R square equals R square plus R square plus 2RR. R square cancels, R square, I forgot to write one small R square here as well, 4 small R squared, right? And this small R square also cancels. So I'm getting 4r square equals, this goes over there, 4 plus 2, 6r. R and R cancels, and we're getting 4r equals 6r, or small r by capital R, the required ratio is 4 by 6 or 2 by 3. So it's option A. Right. Right. Circle questions. Try to use right triangle geometry. Try to do the required construction. Right. Obviously, this question requires a little bit thinking. Does not strike immediately, but this will, I hope, go a long way in uh, helping you deal with similar questions that might come up. All right. All right. Oh my God, modulus. Next one. Right. Modulus, which of the following is true for the function given above below? So you have to analyze this function. Now, we have seen a lot of questions of modulus in my sessions. I hope you have been with me. And so I brought a different flavor of modulus today. We have seen questions involving two modulus terms, three modulus terms. Now, you can have as many as you want. There are 5 terms here. And the options are all about, whether the function has minimum or maximum value of how much for how many values of x, right? Minimum value of 3 for 2 values of x, maximum value of 3 for 3 values of x. So what is that all about? How do you find that whether this function has the minimum or maximum value at how many values of x? Now look at this overall function. It has how many terms? 5. The first term is with the positive quotient, right? Then the negative, then the positive, then the negative, then the positive. How many positive terms are there? There are 3 positive terms. How many negative terms are there? 2 negative terms. So when x is very large in magnitude, let's say x is 10 billion, something very, very large, will this value overall of fx be going towards plus infinity or minus infinity? I am trying to just eliminate 2 options before I start to solve the question also. Because I know that when x will be very large, as x approaches large values, whether positive or negative infinite values, fx will approach how much, what kind of values? Since there are 3 positive terms and 2 negative terms, so overall 3 positive, so more positive terms are there, so overall the net effect is positivity. So fx will approach plus infinity for very large values of x. What I'm trying to say, this function will not have an absolute maximum value. The absolute maximum value is unbounded, it is going towards plus infinity. So option B, right, and option D are straight away ruled out, because this function will not have an absolute maximum value but an absolute minimum value, because the maximum value is unbounded, it is infinite, it is infinite, right? First of all, that we can do, and we are left with options A and C. Now we have to solve this. Okay, so now what we can do is, we know that whenever mod terms are there in bunched together in addition or subtraction, the graph of this function is always a set of connected line segments, like a zigzag pattern is there, something like this, something like this, and wherever these breaking points there are of the graph, this function has the breaking point at 1, 2, 3, 4, and 5. So at those points the graph will change its direction abruptly, and there is, that there we have the possibility of getting the maxima or minima, right? So we have to simply do one thing, repeat a process 5 times, find the value of f1, f2, f3, f4, f5. That will resolve the debate that what are the minimum values and how many times we get that. So quickly calculate this. What is f1? 0, minus 1, plus 2, minus 3, plus 4, because the values will only keep on increasing as we put 1. So 0 and then 1 in the mod with sign, and then minus plus, right? So 0 minus 1 plus 2 minus 3 plus 4 equals this is what, 6 minus 4 plus 2. F1 is plus 2. F2, so 1 minus 0 plus 1 minus 2 plus 3 is 3 plus 1 4, and 5 minus 2, this is plus 3. All right. What is F3? 2 minus 1 plus 0 minus 1 plus 2. 2 and 2, 4 minus 2, this is plus 2. So definitely F1 and F3 look to be the minimum, right? Because F2 is higher than that. Let's quickly find F4, F5. That will finish the things. F4. So 3 minus 2 plus 1 minus 0 plus 1. Correct? Is 3 minus 2, 1 plus 1, 2 plus 1, 3. So this is not the minimum. This is not the minimum. This is not the minimum. This is the minimum. This is the minimum. Right? So the minimum value is 2 clearly, and therefore clearly option C is the correct choice. It has an absolute minimum value of 2 for 3 distinct values of x. The third value is F5. Right? We have already solved this, but you can confirm, yes, F5 is plus 2 because you get what? 4 minus 3 plus 2 minus 1 plus 0, which is plus 2. All right. So what's the core idea of this question? This, that a graph of several modulus terms in addition or subtraction is always a zigzag pattern, and those bends or those sharp changes in the direction of the curve happens at the breaking points of the modulus terms, right? Which in this case we have 5 such breaking points, 1 2 3 4 5. So just find the value. So actually I can finalize that the graph of this graph should of this function should look something like this, that it starts from somewhere infinity, then at 1 it is 2, and then it is at 2 it is 3 comes up, then at 3 it is again 2, then at 4 it is again 3, then at 5 it is again 2, and then it goes up again, right? Something like this is the graph of this function. All right, so I'm trying to get the basic concepts clear over here of how modulus term different terms are there. How do we get their graph? Just find the value of the graph at the breaking points, and you can get the graph. And overall, you have to look at how many terms overall there are. Are they overall net positive or net negative? Right? That will tell you whether the graph will go towards plus infinity or minus infinity for large values of x. All right, people. Now, something interesting. Something interesting. I've brought a very good question, I guess. Maxima and minima. Very carefully worded problem. So I'll let you digest and try to attempt this question for 2 minutes. I'm giving you 2 minutes. Please try. Okay. So do let me know if you're getting this. Now, what this question is all about. There's some group of numbers which add up to 1,000. How many of them are there? We don't know. The question says maximize the number of such numbers whose sum is 1,000, given that they are positive integers, right? And this thing, look at this, tells us basically they are distinct. this second part, the second statement, x1 less than x2 less than x3 and so on. Right. So basically telling me that their numbers, none of them can be the same. They are distinct positive integers adding up to 1,000. I want to maximize the number of such numbers which add up to 1,000, which are distinct integers. If I want to maximize the number of numbers, I would want the value of the numbers to be as small as possible, which is I would start with the least positive integer. What is the least positive integer? What is the least positive integer? Tell me on the chat box. सबसे छोटा पॉजिटिव इंटीजर कौन सा होता है? It starts from right. We start from 1, and then we need to go further ahead, right? We cannot have one repeat. Then the next one needs to be 2. So what we would want, we would want x1 to be 1. Then we would want x2 to be its then least possibility, which is 2. क्योंकि हम we are trying to keep the values as small as possible. So after 1 we have to go to 2. We are forced to go to 2 because they are distinct. Then we are forced to go to 3. Then we are forced to go to 4. x1, x2, x3, x4 and so on. We would want them to take the values 1, 2, 3, 4, 5, 6 dot 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 until we reach a stage when the sum of these numbers has reached or is just below, just short of 1,000, so that if we add the next integer, we cross the level of 1,000. So basically we are looking for the sum, which is 1 plus 2 plus 3 and so on, up to some number, let's say k, to be either less or equal to 1,000. We want this sum to be less than equal to of 1,000, right? We know this summation is k plus 1 by 2. The sum of the first n natural numbers is n plus 1 by 2. I'm using the variable k because n is already used in the problem, right? So k plus 1 by 2 is less than equal to of 1,000. Okay, so k into k plus 1 is less than equal to 2,000. Now I want k to be as large as possible, right? What is the maximum value of k such that k into k plus 1 is less than equal to 2,000? Now k into k plus 1 is very near to k square for large values of k. I can approximate k plus 1 as k. So this is almost k square. This is approximately k square less than equal to 2,000. So which perfect square is near to 2,000? 40 square is 1600, 50 square is 2500. This is almost mid of 16 and 2500. So it looks like somewhere in the around the range of 45 or so we should reach the mark. Let me try with 45. What happens? K equal to 45. If I put k equal to 45, then what is the value of 45 into 46 by 2? Which is 45 into 23. Well, 45 into 20 would be 900 and 45 into 3 will be 135. So this has crossed the level of 1,000. This is 1,035. Okay, so if 1,035 has been reached at 45, then what is the sum of 40 till 44 numbers? I need to subtract 45 from 1,035. Over here, I had got 1,035. So can I say 1 plus 2 plus 3 plus 4 up to 44 is basically 1,035 minus 45, which is 990, which is within the range, which is what I want. So 44 is the maximum that we can take. Now, none of you have understood the question, right? Thank you for trying, Prashant and Orangutan. But the point is, you've not understood the question. Question is not asking for the value of n, my dear friends. Question is asking, look at the question. You forget to read the question. You think now, okay, I'm solving for k, whatever k I get, I mark the answer, and my answer is 44. You have not read the question. Let 8 denote the maximum possible value of n, and we have got that value is 44. But question is not asking for the value of n. Question is asking if n equals 44. If n equals 44, what could be the maximum possible value of any element in set S? Remember your primary constraint. The sum of these the sum of these n numbers is 1,000, exactly 1,000. But your sum of 1, 2, 3, 4 up to 44, if you're doing, is 990 and not 1,000. So the thing is, to these 44 integers that you have written from 1 to 44, you need to add you need to add something to enable it to reach the exact value of 1000, which is you need to add a 10. And this 10 cannot be a separate integer, because remember 10 is already included in this list of numbers. So this 10 is that incremental value which has been which needs to be adjusted by distributing amongst the remaining numbers. And the question is asking, what is the maximum possible value of any element in set S? Right now, the 44 elements that are there in set S, the maximum value is right now 44. You would obviously want this 44 only to be further maximized, which is that you would want this remaining value, which is the remaining value that needs to be adjusted to reach it to 1000. You want this 10 to completely be assigned to 44, so that 44 plus 10, which is 54, becomes the highest possible value of any element in set S. Read the question, my dear friends. You get lost, you get um, overpowered by the way of what you're solving internally to reach to the answer, and then you forget what the question, you forget to read the question. And that is I have seen the most common mistake that happens with us. We get lost in terms of what we are solving for. We forget what is the objective. We forget to read the question. We create a variable, we solve that variable, we just mark the answer as whatever that variable we have taken. We forget what the question is asking. Don't forget to read the question. I cannot emphasize it anymore. Right? Okay, so good that you participated. Good that we are learning. Right? Thank you. Let's finish this session with another interesting question. Right? Next one. I think this should be a good question to conclude with. A one-liner. Not all questions that are lengthy to read are difficult, and not all questions that are short to read are simple. Right? Let's try. I'm giving you a minute or so. Okay, I'm giving you one more minute. I want some response on this, right? I don't want to just give it away. Let me see if somebody can get this. Yes, orangutan. Very nicely done. You should not be doubtful. That is correct. Yeah, Prashant. Okay, Prashant also got this. Very good. Shabash. Nice. Right, so let's finish this, people. Thank you. Thank you. Good, good, good. Right, so in any digit problem, the primary constraint without being mentioned is that the leading digit needs to be non-zero, right? So apart from the fact that one needs to appear exactly once, zero should not appear at the thousands position. So always, that creates a distinction between putting a value at the thousands place and putting a value at the other three positions. So definitely this question requires us to form cases, for the reason that one has to appear exactly once. If I put that one digit 1 at the thousands place, then the number of options for the remaining three places, the remaining three place values, which is the hundreds, tens, and thousand units place, will have a different number of options. But if I put that one at any of the other three positions, which is either the tens, units, or hundreds positions, then the number of options for the remaining three digits are something else, because at the thousands place there is one more constraint. So we need to form cases, two cases basically. Case one, that one appears at one of the last three positions, right? One appears at either the units or the tens or the hundreds place, right? So therefore, uh, three ways. So I'm writing the number of ways over here. Three ways that where you're putting that one, right? That one is going either here or here, right? So let's say that one, I'm just writing for the purpose of explanation. Let's say that one comes over here. Three ways it could have come. Then at this place, 0 also can't come and 1 also can't come. So at the thousands place, then we'll have 8 ways to fill that position, right? And the other two places, we only have the constraint that 1 won't come. So they will have their 9 ways. So 3 times 8 times 9 plus the second case, which is that the 1 appears at the thousands place. So we are fixing it here only, and right, so that is done, right? Nothing needs to be done for the thousandth place. Other three places will have absolutely no restriction, except for one can't come over there. So each of these three places will have simply 9 ways. So 9 into 9 into 9, right? So you just multiply and add, you get your answer, which is 2673, right? Brilliant. All right, so thank you people. Good session, I guess. I mean, I enjoyed it. I loved your participation. Good. All right, thank you people, thank you so much. uh just to remind you, we are on your we have launched our mobile app as well. It's there on iOS as well as Android. If you're not aware, you can make use of this in your journey for cat, right? Maybe it can help. Okay, so thank you people, thank you so much. It was a lovely session. Stay connected, stay in touch. Right, let's see you next time. Thank you. Thank you.